Technical Corner.
Today I'm joined by Paul from ITC and we're going to be talking about just some of their drills. Paul, obviously we've got two different drills here. One's a solid, one's an indexable. But is there a crossover, and tell me more?
Yeah, once again, just demonstrating that we're going beyond solid carbide. The VDS is a solid carbide drill produced by Widia. It is probably now our most commonly used solid carbide drill. It's offering a program that takes you from 1mm diameter up to 20mm diameter. And although it's in our slimline catalogue at very competitive prices, the larger diameters do start to get expensive. So you'd find a crossover now going into the indexable product, where you can take from 12mm up in a camlock head, or there is a traditional U-drill program available as well. So then we have a full ground carbide head. So unlike a spade insert, it's a full ground geometry for the various materials, and there are different grades and different styles of grinding available for the different materials. That head then camlocks into the body. So it's a very simple process of aligning it up, and with the spanner that would twist and lock into the body. Once that's locked up into the body, you're ready to go. That can remain in the tool spindle, and when the head is worn, you can actually put the key in, unlock the head whilst it's still in the machine. So it's a very, very quick exercise to actually change the insert as well.
Sure, and this, correct me if I'm wrong, but this holder will take a number of different diameters. You don't need a different holder for a 16.5 to what you would for 16.4, for instance.
Yeah, it's a range, so it does jump in 1mm diameters. So the heads are produced in 0.1mm incremental sizes. The bodies are produced in 1mm incremental sizes. So anything up to 18mm will be dealt with on a 17mm shank, and so on.
But the important thing to mention is, once you've bought the holder, you only need it once, whereas if you were buying a 16, 17mm solid carbide drill,
correct,
expensive. Sorry, not expensive, but more money to buy.
Yes, I mean, you can have a solid carbide drill reground. There is a time implication with that. It does add to the cost effectiveness of using a larger diameter drill. Whereas this solution, the cost of the heads is only fractionally more than a regrind price on a larger drill, and you're getting a brand new unit every time. As I say, you haven't got to take that drill out of the spindle to actually replace the head, so the interchange is very, very quick. And obviously, in a production environment, because that is cam locking into a body where the length's already set, you haven't got to then go through your pre-setting routine as well. So on larger diameter drilling, this is probably a better option. Sure.
In the VDS drill, I've seen hundreds of these in the field, and it strikes me it doesn't look correct, does it? It almost looks like a scrap drill, doesn't it? You know, there's very little margin here, if any at all. It just looks like a blank.
Yeah.
But very successful.
It's a very, very successful drill. We've now applied it to a whole raft of materials, from aluminiums, would you believe, going all the way through to high-end aerospace materials. It just seems to perform. Obviously running at the right feeds and speeds, and having the actual 0.1 incremental sizes going through from 1mm up to 20mm diameter in 3, 5 and 8 times diameter drill lengths as well means the program is very, very good.
And these are great for machining centres, but if we've got a lathe, what would you put on the lathe?
Once again, it's really demonstrating that we've got more than solid carbide now, offering the customer the solution they require for their machine and for the application. We can go in and actually advise them on which product would be best for their application and supply that to them.
And what else do you have? Do you have like an ISO type insert program?
On the drills, on the U-drill, the Top Cut 4 as it's called, is actually a very specialised U-drill. They use two different grades of carbide, one in the centre and one on the periphery of the drill, which both have 4 edges. So cost effectiveness again is very, very good. They're aiming at high performance all the while, and that's obviously a solution that you can go up to 68mm diameter, I believe.
So again, you're down at 1mm, maybe even below, or 3mm certainly and below, but you can go right up to the big U-drill sizes.
Yeah, so the VDS drills start at 1mm diameter. Through coolant variants of that start at 1.5mm diameter and go all the way up to 20mm diameter. The TDM drill here interfaces in between, going from 12mm up to 28mm, and then the U-drill over and above that going up to 60mm.
Well, there we have it. Big range.
Very big range.
So ITC, not just milling, not just tapping, Not just turning, drilling as well.
Yeah.
Thanks, Paul.
Thanks.